Years ago, I had a student we became close friends with, and I invited them to my church, and they showed up, and my wife's an introvert, so people never. I have friends who have had for 15 years who've never met my wife. My close friends I have met my wife before, but anyways, the student goes up to my wife and says, "Oh, are you Mrs. Littman?" And then she goes, "Yes, what, like, what do I have to apologize for?" That was her starting point, is wanting to know what she needed to apologize for, something that I must have done that has caused her to go to the boss. I'm like a giant 2-year-old. I embrace it. All right, online GDP, right? All right, we're creating our diagonal. Is that right? Somebody want to kill the lights or do whatever makes you happy? I don't care either way, but just all right. And I started the recording. We are sharing. Okay. No. Yep. I'm going to do the diagonal one today, and then there won't be homework over Easter. And then when we come back, we'll connect our back end into our front end. Okie dokie. So disable hide floating media controls. All right. So over here in our Connect 4 board, where we're checking for is winner, we're passing in our move result. Remember, our move result just has a collection of information that we got after a successful move, row, column, color, so we have those things. We are going through, we've already done the check for vertical and horizontal. So the vertical check, we only needed to check from the last move position down below it, because we knew there was not going to be any checkers above that guy after a legal move, just the nature of Connect 4 and what a vertical Connect 4 would look like. So we tested that. That's all working. That's what this is. We basically just go and we just count as many checkers in a row that are the same color as possible. As soon as we find one that isn't the same color, we break out. We check. Did we find at least 4 of them? Found at least 4 of them. We must have a check Connect 4. Since we're checking after each move, we expect we'd find exactly 4 of them. But as long as we find at least 4, we're good. For horizontal winners, we started off with our starting place. So we had our horizontal count of 1. We counted the move that we already made as part of our potential Connect 4. Then we went as far left as we could. So we started at the starting column -1, kept going potentially all the way to the left edge of the board, which is column 0. Each time through, asking, first of all, is there a checker here? Because there's no guarantee that we even have checkers in the board to the left of us. So as soon as we run into an empty spot, we want to get out of dodge. So if we run into something that's not a checker, which would be null, break out of this loop. We've counted as far as we possibly can count. Otherwise, we grab the checker that we're looking at somewhere to our left. We get its color. We ask if its color is the same as our winning color. If it is, we increment our horizontal count. We found checkers in a row that match the color of our last move. Otherwise, we have found something that's a different color, can't go any farther, we break out. So at this point, horizontal count has been partially filled up. We've counted as many checkers as we can to the left of us. Now we want to go and do the identical thing to the right of us. So the right of us, we're going to start at the column immediately following where we made our successful move. So start column +1. Keep going until we run out of columns. So this would be columns -1 is the last legal bucket, right? There's 7 columns. Then we have 0 through 6 are the legal things. And if you remember up here, we have columns starting off at 7, which is why we are saying keep going as long as it is less than the number of columns. All right, and then we're going to increment those columns as we go. So we're starting at the column just to our right, then the one to the right of that, then the one to the right of that. So we're adding 1 to the column we're checking each time. Again, make sure we're looking at a checker. If we're not, we've gone as far as we can. Otherwise, get the checker, get its color, ask if its color matches our winning color. If it does, increment our horizontal count. If it doesn't, we've gone as far as we can to the right. because we hit something that's not the same color as us, so it's not going to be part of our win. So we'll go ahead and break out. When all is said and done, we'll ask the question, did we find at least 4 checkers horizontally involving the move we most recently made? If we did, return true, there's a winner. All right, so far so good? All right, so now we want to do our diagonal. Now the diagonal is going to be very similar to the horizontal, with the exception that not only when we move to the left, we're also going to be moving up and we're also going to be moving down. So we kind of have to do four ninja moves, maybe. We probably want to do it as 2 separate groupings. So we're going to do a potential connect 4 that would be from the left down to the right diagonal, and then another potential connect 4 from the left up to the right diagonal. All right, so let's handle those as 2 different cases. But otherwise, each of those is, we have a line of potential connect 4, but instead of just the rows changing or just the columns changing, both the row and the column will change as we're moving. All right, so we started off writing this. Let's see, move that. All right. So we started this guy. We started a for loop, and I mentioned that for loops, even though we've always written them typically to have a single introduced variable, a Boolean expression, and then a single change to our variable, technically for loops allow us to define as many variables as we want, and it allows us to change as many variables as we want. It does require us to only have a single Boolean expression, but we can build a super duper Boolean expression, a complex one, right? So we're going to start I off at our start column -1. So we're already counting our possible diagonal up left to down right. We're starting that off at 1 checker because that's the move we've already made. So we're going to start our column off 1 to the left. We're going to start our row off 1 up. So I and J are our rows and columns here. As long as I is greater than or equal to 0. So that's our, you know what, this might be, do we have row and column in here? Whatever, let's keep going with it. It's always fun to be confusing. All right, so I is our columns, J is our rows. So as long as the column we're currently looking at hasn't walked off the front of the left side of the board, so as long as we're greater than or equal to 0, and the row we're looking at hasn't walked off the top of the board, we are still potentially at a legal location in our on our board, right? All right. So then we're going to ask the question: is the thing we're currently looking at a checker? Same question we asked before. We don't want to check something's color if it's not a something. So if it's not a checker, we'll go ahead and break out. Diagonal up left down right count is already started at 1, so it's gone as far as we can in this particular direction. This is the direction to the left and up. All right. So as soon as we run into something that's not a checker, or we run off the end of the board, or the next logic. So when we get to this line right here, we know we are actually looking at a checker. The current row and column we're looking at, column I, row J, is a checker. So then we're going to grab that checker. We're going to get its color. We're just forcing these into variables. We could have just used them from the board directly, but I wanted to break them out, so we're operating off of it. So we grab the current checker. We grab the current checker's color. Then we ask the question, is the current checker color the same as our winning color? If it is, so far, so good. We add 1 to our horizontal count. Loop ends here. It spins back up. It will move left another column, up another row. Check that again. All right. As soon as this else will be if we run into something that is not the same color as us, which means we've moved as far as we can in that direction. We have our count updated as far as we can go. All right, now let me Let me just gut this so we'll grab our same stuff from before. All right, so this is our check. Here's my errors that I put in there. So this is diagonal up, left, and down. So this is to the left and up. So now we need to go to the right and down to get the other part of this. So we'll grab this for loop. Now do right and down. So paste this back in there. So we're going to have our start column be the column to our right, +1. We're going to have our start row be 1 row down, +1. Keep going as long as our column, we're not concerned about going off the left side of the board. Now we're concerned about going off the right side of the board. So keep going as long as our column is less than this dot columns. So in our case, columns is 7. So as long as whatever I currently is, which represents our column, as long as that has not walked off, as long as we're not looking at bucket 7 or larger. All right, because those aren't legal places in our grid. So as long as that's true, and we want to make sure our row, since we're going down, has not exceeded our number of rows. So as long as J is less than this dot rows, which is 6, if you remember from up here. So the legal rows would be 0 to 5. The legal columns would be 0 to 6. So if we're looking at a 6 or we're looking at a 7, we're not in a good neighborhood. All right, that would be a null pointer exception or C-sharp's equivalent to that dude. All right. All right, so start column 1 to the right, start row 1 down, keep going as long as the columns are legal and the rows are still legal. Each time through, we're going to be incrementing our columns because we're moving to the right. Each time through, we're going to be incrementing our rows because we're moving down. And our top row is bucket 0, moving down. All right, so then we're asking the same questions. Are we looking at a checker? If not, we're done. We've done as much as we can. Otherwise, grab the checker, grab the color. Is the color equal to our winning color? If it is, and I already see I had a bug up here. Remember, we are updating our diagonal up, left, down, right count. It's a mouthful. All right, so I went back to the previous for loop right now because remember we started with our loop from our horizontal count as our baseline. So I'm still adding 1 to that guy. We want to actually update diagonal up, left, down, right count. All right. Similarly, in the second for loop, we also want to add to that. All right. So as long as we're looking at a legal place and it matches the color that we're going, add on to our diagonal up, left, down, right count, spin back up, keep trying until you run out of space or hit a color that's not a legal color. Otherwise, that else says, hey, we're looking at a checker, but it's not the same color as the potential win, so we need to get out of Dodge. So right after these 2 loops, I now want to ask a question about my diagonal up, left, down, right count. All right, so was there a winner diagonally from upper left to lower right? So we'll say if that variable, diagonal up, left, down, right count, is greater than or equal to 4, then we're going to return true. All right, good with that? All right, so just for a second here. That way I can visually find the spot again here in a second. So I'm going to scroll up. I'm going to copy both of those for loops. I'll grab this variable. We'll obviously rename our variable to be just as confusing, but a different name. So we'll paste this here. So we'll say check for diagonal, what is this? Lower left to upper right. I'll paste all that stuff in there. So we're working right here. So diagonal, lower left, upper right, count. All right. And just so I don't forget, I'm going to go ahead and copy that. And let me go ahead and update my pluses here with the updated variable that we're actually counting. Similarly, after we finish our check, if that guy is at least a 4, return true. All right, so now let's walk through this and make sure we're checking this correctly. All right, so if we're going from lower left to upper right, our start column will still be 1 left from where we're starting, right? So this I is correct, but J is going to be our start row plus 1, right? We're moving up. Right, because remember, start row starts off at, actually, hold on, let me think about this. Start row, column is to the left, row would be plus 1 here, so that's still that's going left to upper right. Did we mislabel our thing up here? Start column, start row, so that be, and then we're subtracting from row, so that would have row going down. Okay, so it's on the math on the other side. All right, so we will start at our column 1 to our left, row 1 down. We're going to upper right. Super ninja. Let's look at our picture. All right. So this guy right here, here's our picture. Let's assume that the move we just made is this guy, and we're checking from a lower right to upper left. So column is going to be left 1, so -1. Row would be left 1 plus 1 to move here, because we're checking this diagonal, and the one we did before, we checked this diagonal. So let's confirm the previous ones that we did it right before we go on to the second one. So for our left side of our diagonal up here, so we're checking for diagonal winners. We're trying to go from upper left to down right. So our intention was to check here, here, so on and so forth, to here, so on and so forth. So our starting one, if we're going to the left, should be column -1, row -1. This is the 0 up here. Let's double check that. Column -1, row -1. Okay. And then how are these guys changing each time through the loop? Because our loops are identical, right? You know, our loops are doing the exact same math or exact same questions as we go through there. We just need to make sure we're looking at the right part of the board. So if we are doing upper left to lower right, we are checking this diagonal here. So if we start off here and we are moving farther left, then we are going to subtract from column and subtract from row to get to there. Subtract from column, subtract from row. That looks correct to me. Good? All right. Next one, we're doing the right half of that guy. So now we're starting here. So that means column is +1, row is +1. Column is +1, row is +1. Now, how is that going to change? Let's pretend we're not off to an illegal place here. So as we move, we'll have column will be +1, row will be +1 to get down here, right? Column is +1, row is +1. All right, so it looks like we're doing that one correctly already. We're good with that? All right. So again, this is drawing pictures is helpful for this. So now we're looking for lower left to upper right. So let's go back to our picture. So we're trying to detect a diagonal here, lower left to upper right. All right. So we are going to have column -1, row +1. That's our starting point. Column -1, row +1. Okay. And how should they change as we go through here? It's going to change where we have column -1 and we have row +1. So that is column -1, row +1. All right, makes some sense. All right, so then we're asking the identical questions that we did before, going through there, breaking as soon as we have counted as many things as we can count. Now we're doing the right and up. So we're looking for this move right here. So now to go to the right, we're going to say column +1, row -1. Is our starting point? Column +1, row -1. And then how do those guys change? They're going to change, and we'll go back and look at our Boolean expressions here in a second. Those guys are going to change based on our column +1 and row -1. So column ++, rows -. All right. So as our column is going to the right, we need to make sure we're not running off the end of our board. As our columns are going up, we're not interested in being less than rows. We're interested in being greater than or equal to 0. Why? Because as we're moving up this way, the possibility is we try to hit a row above the top of the board. And that's my brother cheating ninja moves. All right. So that's our Boolean expression there. Let's confirm the one above it as we're going diagonal down. So we are checking this side of it right now. So this side here, we want to make sure our column is greater than or equal to 0, because our chance of failing is going off the end of here from a column perspective. So column is greater than or equal to 0. And row, since we're going down this way, possibility going beyond this dot rows. So we want to make sure that our rows is less than this dot rows. Make sense? All right. So drawing pictures helped us there. Okay. Again, go ahead.
Could you go to the top and look at start row, like at the variable start row at the very, very top?
Oh, like top, top, top?
Yeah. Yeah. So I think when we scroll down, we wrote start row. It's yeah.
Oh. So for is winner.
So for like every time you refer to the start row, you just have to -1.
So let me think about this. I remember having this discussion because when we're checking for winner, we're bringing in the move result. We are assuming that any win based on this, because originally we were just checking horizontal. So we were doing these things. So we want to consider our start row here, because right now I'm making the assumption that the only rows we're looking at is the row right beneath us. It probably makes more sense to have start row be the row. So let's take that +1 off. But we need to go through and check to make sure this didn't break other things. So start row is going to start off at whatever row we made that move. Start column is going to start off at whatever row we made that move. All right. So this guy represents the most recent move we've made, its exact location. All right. So let's see, this is our vertical check first, right? So vertical check, oh, I see we were kind of rating this specifically for the vertical check. Whatever. All right, so we're going to start off at start row for doing vertical will be -1, right? So we're actually going to put the -1 there. Because right now, what we just did is start row used to be this position. Now we move start row to this position, which means that the first place we're going to look for a vertical win is actually start row +1. This is going towards 0, so 0, 1, 2, 3, 4. So we want to have start row +1 is our first thing we're checking for a vertical. Start row +1. Let that look right. All right, and we're going to keep going as long as the row we're looking at is less than our rows. So potentially we can keep going far down this way. So we're going to keep adding 1 to row each time until we either find a checker that's not the same color or we walk off the end of our board. So we need to make sure that I is less than this dot rows. I is less than this dot rows. Increment by I each time. Okay, that one looks good. All right. Our columns probably shouldn't be impacted by our change in rows, but let's just confirm. So we'll start off at our start column. So our start column will be this is the position we're starting with. So start column would be this guy. And we're going to look everything to the left of this guy first. I think is the direction we go, right? So we'll start off with start column -1. That's the position just to the left of that guy. And we're going to keep subtracting 1 from that column. Start from -1, keep going as long as we're not off the end of the board to the left. Subtract 1 from it each time. We look good there. Then we do the other half of the horizontal. So we start at start column +1. That's the column we're going to. Start column +1. Keep going as long as we're less than the end of the board to the right, which is less than this dot columns. Increment by 1 each time. So this will allow us to keep going this way. But as soon as we walk off the end of the board here, we're in illegal territory. We bail. All right. So that looks good. Got a horizontal count. And I think we just went through the logic for this. So if we are still alive when we get all the way down here, if we're still alive, so if we are still alive, there was not a winner and will return false. We have checked every possible thing involving our most recent move. Horizontal, vertical, and diagonal in both directions. Okay. So let me save that guy. I think in our game manager, we already made it to keep going until there's a win. So when we have play in our game manager, we give ourselves the ability for random numbers. We have our array of 2 colors, R or B. We alternate between those 2 guys. We make at least 1 move. That's why we're using a do while loop. So we're using a type of loop that is a post check loop. Post check means we are asking our Boolean expression for the first time after we've executed the body of the loop at least 1 time. All right, so we're going to show the board. We're going to try to make our move at least once. And since we're randomly generating moves here, it's possible we might start stacking checkers in bad places. So we make sure it actually allows us to make the move. All right. But eventually, when we get past line 29 here, when we're on line 30, result will hold the successful move we just made. The rows and columns and the color of the successful move we just made. All right. Then we increment cur color. Now remember, what we're doing for cur color is basically up here. When we make a move on our board, just reminding you that we pass in several pieces of information. It says winner. Oh, here we can Here's our make move. We pass in the column that we're dropping it into because this is how Connect 4 works, right? We just hover a checker above the thing, pick our column and let go. And we're also passing it the color that we're passing in. How do we get the color in there? In Game Manager, where we have our array of colors, this guy right here that has bucket 0, bucket 1. And we are passing, we're getting the element of that, which is whatever the value of cur color is, which is an int that started off at 0, divided by 2, and looking at the remainder. So anything mod 2 has a possible result of 0 or 1, right? So 0 mod 2, 2 goes into 0 0 times with a remainder of 0. 1 mod 2, 2 goes into 1 0 times with a remainder of 1. 2 mod 2, 2 goes into 2 1 time with a remainder of 0. 3 mod 2, 2 goes into 3 1 time with a remainder of 1. So we're just bouncing back and forth between 0 and 1 using just math. You could have also just said if it used to be a 0, make it a 1. If it used to be a 1, make it a 0, and just bounce back and forth that way, if that's preferable. Just as a quick question, why do you think I did it this way rather than throw an if statement in that looks, something like this, like if cur color is equal to 0. Let's just assume that's, then we'll say cur color is equal to 1, else cur color is equal to 0. Why don't I alternate between 0 and 1 with that logic? Why do you think I chose not to do that? It certainly would work, right? Go ahead.
Necessary censoring a logic since you already not straight, but just takes unnecessary.
Okay. So the idea here would be based on, and this is really something that we had to pay a little bit more attention to since we jumped into Unity, where we might be putting stuff inside of our update method, where a lot of crap might be happening every single frame, and frames happen often. So I've kind of advertised that anytime you have an if statement, that's time, right? So if we can minimize our if statements without going crazy with math tricks, because you do have to, consider that as a software engineer, you're likely going to be working in teams, which means that if you're really good at math, or you're one of those problem solver math people who just comes up with crazy algorithms to represent, like, it works, but nobody can follow your math. A lot of PhD students in mathematics who do combinatorial mathematics have some really cool stuff. They tend to be the ones who win a lot of the programming competitions. But you have to basically follow their code by just plugging numbers in and see that it does what it seemingly is doing. Like, you don't believe it. A lot of sine and cosine stuff works that way. Sine and cosine are actually very handy for creating it because they're both wave type things. So if you need something to go up and down, but in a smooth motion, that's sine and cosine, right? So you can use that to produce effectively what does the graph of those look like, right? Remember back in when you had your math classes, you had to graph stuff. Well, some of you are still doing that stuff, right? Okay. And like, well, why am I graphing this? That's why. If you have a function and you can look at what it looks like, and the function behaviorally says, oh, that's the journey I want my number to go on. That could be a function that represents what you're trying to accomplish mathematically. But not everybody's going to be dragging their graphing calculator with them when they're writing their code. So often you want to be as direct as possible, but you hit the nail on the head with minimize your if statements unless there's a really good reason to have an if statement. Any reasonable reason most of the time to have an if statement instead of a crazy math thing is if you don't think other people will be able to follow your code. If you're writing a video game and speed is absolutely imperative, and this is a complex part of the game or something like that, certainly do the crazy math thing and then maybe throw a comment before it that says this is what's happening here. You reference your some diagram on GitHub or something like that for what's happening. All right, so that's why we chose not to do a little if structure like this. All right. And we're doing our little relatively simple math trick with just mod 2. If we wanted to get a value of 0, 1, or 2, we do mod 3, so on and so forth. All right, so we get our legal move. The move has been made. We make sure we set up for the next move, for the next color of the move. Then we check to see if there was a winner. And now our is winner has the ability to also check diagonals, theoretically. All right, so let's go ahead and try this guy. Because right now, the entire program just creates our game manager and tells it to go. Row index out of bounds exception. Okay, so when you see that error, what should be the first thing that's popping into your head? What have we likely done here? Go ahead. Okay, we tried to access a null pointer. More specifically, since it says index out of range, as opposed to null pointer exception. What does index out of range tell us? Go ahead.
Probably off the bounds.
Yeah, we are dealing with a column or a row that isn't a real column or a row. All right, so let's see where it says we ran into that. Obviously, I put the bug in there on purpose, as usual. You're not going to give me like numbers? For is winner, move result. Okay, play. Okay, so it's definitely in is winner. That's a terrible error message. You're not telling me which line of code you ran into that? All right, so let's go. Actually, since we're not making the same random moves, there's a chance we could run this again and it won't have the problem. Since we're not getting any good information here, because we see that we have the errors and index out of range. So I promise you the problem is we're accessing a column that's less than 0 or a column that's greater than 6 or a row that's less than 0 or a row that's greater than 5. One of those 4 things is the culprit here. The issue that unless I'm missing something, and I often do, does anybody see it pointing to the line number where this happened? It's definitely in is winner. Say this again.
I think that might, if it's possible, that has to do with the diagonals that we put in.
Well, I'm guessing, yeah, because that's the new thing we've done. So let's just go peek at our diagonals and see if we see a place where it is likely that we've run off the end of the array in either direction. I think we're fairly confident with what we did with the horizontals and verticals. So let's go into our board. Here's our is winner. Let's go down to the diagonals and see where this is possibly happening. All right, so we know at the very least our for loop here for starting with I is column -1. And we want to consider, let's just look at our board real quick. Is this thing still here? Because we can see what the position was here. All right, so we were right here. So my guess is it's probably a problem with the row. All right, go ahead.
Check for whether the next checker on the diagonal's correct. I don't think it is. So not just checking the next column.
Oh, well, we'll look. Yeah, so let's go look. But we see where the move was. So our first move is right here. So we know that it's looking for a winner off there. We're suspicious that it's our diagonal code we've added. So it looks like it's going to probably be something with our row has now walked off the bottom row, which means that's going to be a diagonal going from left to right and down. But chances are we have the compatible error on the other direction too. Go ahead.
But yes, like so it says in the null check says if the result.row and I or above I right there. So isn't that so?
I see. You're saying the same. Yeah. So we're looking. Okay. Yeah. We were making this assumption that we always check for the legal row the same way. And that's not necessarily a true statement here, right? Because we want to know, is the current place we're looking at a legal position, and we're looking at the board at that's column, and this is row J. Is that what we should be checking? The actual position we're currently looking at. So row J, column I. Row J, column I. Row J. And row J. Realistically, we can change it in the other ones, but I think we probably didn't run into that problem artificially. So JI. And we're out of time, so you can go ahead. I'll just fix it up on those things. So JI. So like I said, no homework over break. Oh, yeah. So we're actually good there. That's why it worked for the columns and the horizontal and vertical, but it's why it's not working for our other ones. So this should now function. Was our last thing. Index out of bounds. So same thing. Very first time. All right. So that tells me that it must be one of the other checks. So I'll look at this, or maybe I'll leave the error and we'll solve it right at the beginning of class next time. It's in one of our if statements where we are technically trying to get a bucket that doesn't exist. We probably have a +1 or a -1 in a bad place, probably with rows, is based on that last experience. All right, everybody have a good Easter vacation. So we are actually back on Wednesday, right? So you don't have to see me for a week. Is that a good or bad thing? All right, well, have a safe trip if you're traveling somewhere, and I'll see everybody in a week. Classes aren't in session Monday until what, after 4 p.m., I think? I think if you have a class on Monday that's after 4 p.m., otherwise it's what, Monday. So it's part of our Easter break. Yeah. So that's not just my class, that's all classes. I'll be in the CAF, but I have my computer science faculty meeting. But I'll be there after. I mean, if you need to chat, I'm done at 1. Oh.